The dimensions of a matrix, you go rows by columns. So you count the number of rows by the number of columns, and that's how you determine the size. So here's a matrix. Now that does not say 6,274. That says 6274 as separate numbers of the matrix. Okay, and so that matrix is 3 rows by 4 columns. So the dimensions of that matrix is 3 by 4. It's not 4 by 3. That would be wrong. It is 3 rows by 4 columns. That's why Randy Crump is painted on the wall, so you know that it is rows by columns. Okay, over there under the air conditioner. The matrix with a vertical column 1, 3, 6 has 3 rows and 1 column. So it has dimensions of 3 by 1. Okay? So that's how you do the dimensions. Rows by columns. Randy Crump. Okay? So, here's an example of a matrix. The way I do softball stats, put them in a matrix, grid them up. Here's the 2013 Eureka Middle School softball stats. Names redacted. That's just one example. A few years ago, we used to do Name That Tune with the teachers, and we would tally the results with a matrix. There's all kinds of ways. Anybody you work for, any boss, will have to do inventory or payroll or whatever with a matrix. If you've ever used Excel, Google Sheets, whatever, that's all, when you put numbers in there, examples of matrices. Test scores. These are not the test scores from yesterday. These are old ones. You can put them in a matrix to see how the scores grid out. Okay? So you get what a matrix is. Matrices are equal if their dimensions and their elements are equal. That is a very simple statement, basically saying two things are the same if all their parts are the same. Okay? Same is true with matrices. Matrices is the plural for matrix. So if I have these two matrices, dimensions would be 2 by 1 for each of them. And I want them to be equal. What you do is you take each element of the matrix and you set it equal to its corresponding element. So you would set, in this case, the top equal to the top. 4x equals negative 16. And then you would solve it for x. X equals negative 4. And then you would set the bottom equal to the bottom. It might be a 2 by 2. In that case, you'd set upper left equal to upper left, upper right equal to upper right, lower left, whatever. Okay? It's not always a 2 by 1. And then in that case, z is 6. So you're just setting corresponding elements equal to each other and solving. Do you think you can do that? It's pretty simple. It can get a little difficult though. Let's show you an example of one that's a little more difficult. We have two matrices here. Again, they are 2 by 1, 2 rows by 1 column. On the left, we have 2x plus y. That's one element of the matrix. And on the right, we have 6. And on the bottom, we have x minus 3y. And on the right, we have 31. They are both 2 by 1, so we can set them equal to each other. We can set the elements equal to each other. And when you set the top equal to the top and the bottom equal to the bottom, you have a system of equations. Do you remember how to solve a system of equations? Using substitution or elimination? Do you have any memories of that? From chapter 3? What I would do is multiply the bottom one by 2. That gives me matching 2's in the first column. Subtract straight down. You get 7y equals negative 56. So y equals negative 8. That process was something that we did, I don't know. It was probably Halloween this year that we were doing chapter 3 towards the end of the first 9 weeks. Now we have to figure out what x is, so we put the y back in somewhere. And solve for, that's an x, solve for x equals 7. So if I put a 7 in for x, this is going back to finding the mystery number that we've been doing all year. I want to find the mystery number that would make the left side equal to 6 and 31. And if I put 7 in for x and negative 8 in for y, that left side matrix becomes 6 on top and 31 on the bottom. Okay, so we're kind of reverting back to our original philosophy of the class, which is find the mystery number. Okay? That's about as difficult as today gets. That's the problem right there. It's all easier than that from here on out. Now we're going to go over a few concepts that are things that you did with Mr. Sin or in your IXL class, maybe, just to review. Scalar multiplication is taking a number times a matrix. So you're taking a number k, whatever the number is, times any size matrix. It does not have to be a 2 by 2. It can be anything. And all you do is you multiply all of the numbers in the matrix times k. It's basically a distributive property type situation. So Ka, Kb, Kc, Kd. All right. So here's an example. 5 times that matrix. That matrix has a dimension of 2 by 3. Multiplying it by 5, you just multiply all the numbers in it by 5. You end up with negative 20, 5, 0 on top, 30, 0, 25 on bottom. The next concept is adding or subtracting matrices. If you're going to add or subtract two matrices, they have to be the same size. In this case, I have 2 by 2s up on the screen. Okay? They have to be the same size. If I give you a 2 by 2 plus a 2 by 3, that's a guppy. Can't do it. As long as the two matrices are the same size, you can add or subtract them. And all you do, first of all, the answer is going to be the same size. 2 by 2 plus a 2 by 2 is a 2 by 2. When we get into multiplying matrices, that's not always the case. Multiplying matrices, which is what we're going to do tomorrow, that's a completely different animal. That's why you did not do that with Mr. Sin, because that's harder. Put that away. All we're going to do is add the corresponding elements. 4 plus 7 is 11. Negative 2 plus 5 is 3. 3 plus 6 is 9. 8 plus negative 2 is 6. Subtraction would be the same. Subtracting the corresponding elements. As long as the dimensions are the same, you can do that, regardless of what the dimensions are. So I'm going to, let's look at another example first. We have two matrices. They are both 2 by 3s. Okay? So we can add them because they have the same dimensions. And we're just going to add the corresponding parts. Negative 1 plus 8 is 7. Negative 4 plus negative 5 is negative 9. 3 plus negative 4 is negative 1. 2 plus 3 is 5. Negative 2 plus 1 is negative 1. Negative 1 plus 6 is 5. So here are the 3 examples I want you to try. Go ahead and get answers. We'll go over those in a couple minutes.